All right, for these problems, they really are just normal probability problems. The only thing you have to think about is what is the mean, what is the standard deviation, and then you will solve them the exact same way as we did before with the equals norm dot dist, a function in Excel. So this says historically 22% of adults in the state regularly smoke cigars or cigarettes. So this population proportion, 0.22, that's going to be the mean. All right, so when we start computing probabilities, we're going to use 0.22 as the mean. The Public Health Department commissions a survey of 1,500 randomly selected adults. So now what we're going to do is we're not going to say what is the probability that one person smokes out of it. No, what we're going to do is say if I take samples of size 1,500, what's the probability that the proportion is going to be less than 15%? What's the probability that the proportion is going to be greater than 22%? What's the probability that the proportion of my sample is going to be less than 35%? For example, for this particular problem, they're saying, assuming the population proportion of 0.22 is correct, what is the probability that 279 or less say they are smokers? So a lot of problems will just give you, they'll say, what is the probability that less than 0.13 are smokers, just as an example. This one doesn't give me the actual proportion. It doesn't say what's the probability that less than 14% of the sample, whatever. What's the probability that more than 77% of the sample, whatever. This one phrases it a little differently. It just phrases it in terms of um, 279 out of 1,500. So it is a proportion. It's just not phrased exactly that way. Okay. So the sampling distribution of our sample proportions is going to be normal, where the mean, as we said, is the population proportion, 0.22, and the standard deviation is this thing. It's basically the square root of 0.22 times 1 minus 0.22, which is 0.78. You can just do that in a calculator if you want, divided by the sample size, which in this case is 1,500. All right, so let's rephrase what this problem is asking. It's asking me, what is the probability that if I take a sample of size 1,500, that in that sample, my proportion is going to be less than 279 divided by 1,500. So we're just, like I said, we're just going to solve these using the norm.dist function like before. So let me bring that up. Equals norm.dist. For this particular problem, they don't say what's the probability that less than 14% of the sample, what's the probability that less than 18% of the sample. If they did, you put in that proportion here for your x value. But since they don't give it to me here, in other words, we're trying to find the probability that the proportion is going to be less than 279 divided by 1,500. I actually have to put in 279 divided by 1,500. Okay, that's my x value. My mean is just the population proportion, which is taken to be 22% or 0.22. And the standard deviation is this slightly complicated square root down here. So I'm going to write SQRT, and then in parentheses put what I'm taking the square root of, which is 0.22 times 0.78 divided by 1,500. And I hit enter to get my answer. No, I don't. Oh, I forgot. Yes. I always end with 1 to find the probability. Okay, now we're good. I have my sample value, I have my mean, I have my standard deviation, and I always end with 1. Okay, so this means that if the population, this means that if 22% of the population smokes, then the probability of taking a sample of 1,500 people, the probability that less than 279 of them say they smoke, is a really, really small probability. It's less than 1%. It's like 7/100 of 1%. But that's the probability. Now, this is just looking ahead to what we're going to do later in the course. If I take a sample of size 1500 and only 279 of them smoke, maybe it's not true that 22% of the population smokes. So we'll look at that later. That's something called hypothesis testing. Hypothesis testing is when they say that the mean is something or the population proportion or something. But then if you take a pretty good size sample and you're pretty confident that the sample is way too different than what you're saying the mean is or the population proportion is, then maybe the population mean or the population proportion are wrong. But we'll look into that later, and it's basically um, doing what we did here. If the probability is way too tiny, we kind of say, yeah, there's a chance this sample was like such a fluke, or I'm guessing that maybe our assumption about the population parameters are wrong. And in that case, this probability is something we call a p-value, but we'll get more into that later.